All right, how's everyone doing? Welcome to lesson 7.4. So this lesson today, I'm going to talk about the following. I'm going to just remind you about slope, talk a little bit about that because the things that we're looking at today revolve around that concept. I want to go through two more types of questions that you might see on quizzes and tests. I want to introduce a new thing called point slope form. Point slope form is a little bit situational. You use it sort of just at certain times. And then I'm going to show you two or three examples of when you would use point slope form. And that should do it today. So here we go. Now remember what slope is. We know that slope is rise over run, and we looked at it the other day, and we saw this little formula, y2 minus y1 over x2 minus x1. And that's what gives us our slope. And so we use that in a situation like this, where we have 2 points and we need to know the slope of the line in between them. And so we take our formula. It does not matter which one of these two ordered pairs we set as x2, y2. I tend to pick the one that makes the math look a little bit nicer. So I'm going to use this set right here, the -1 and 4, as our x2, y2. Okay, so with that in mind, I am going to solve this. We go and put the 4 minus the -3 over top of -1 minus 3. Did I do that correctly? So that's my y2, that's my y1, that is my x2, and I did that correct. Okay, so that's 4 plus 3 over -1 minus 3, which is equal to 7 over -4. So we have a slope of -7/4. All right, so why are we looking at that? Well, everything that we do today sort of revolves around that. So here is the first type of question that I want to show you today that you might see on quizzes and tests. And you'll notice that the only thing different from what we just did to solve that slope was that in this particular ordered pair, one of the values of the ordered pair is represented by a variable. So this says 2 points, -1 and 4, and k and 8 sit on a line that has a slope of -4. Find k. So I'm going to go back to y2 minus y1, x2 minus x1, and that's equal to our slope. And in this case, I am going to pick this pair to be my x2, y2, because it's the one that has the variable in it. And so that gives me 8 minus 4 over k. There's my variable going in for the x2 minus a -1. And we know, we've been told that the slope is equal to -4. So that gives me 4, because 8 minus 4 is 4, over k plus 1. K plus 1 is equal to -4. Now this looks like the types of stuff we were solving a couple of units ago, where we had to solve for a variable. And so to solve for this, I'm going to multiply both sides of the equation by k plus 1. And that means that this cancels out. And I get left with 4 is equal to -4 onto k plus 1, which is equal to -4k as I distribute this in. -4k minus 4. I then add 4 to both sides, and I get -4k is equal to 8. K is equal to, in this case, 8 divided by -4, so that's going to be a -2. So if the question says find k, we now know that that x value or x variable is going to be -2. So that ordered pair of k8 would be negative 2, 8. Okay, so that leads us on to this next question. And this one is similar to what we just did, with one primary difference. What we just did was we used a given slope along with 2 points to find a variable. Within those 2 points, one of them had a variable in it. In this case, we're not given the slope at all. So I've sort of got to do a combination here. I'm going to take my original or my usual equation for figuring out a slope. And I'm going to use these 2 points to derive that. So I'm going to say that I'll go and say that that's negative 5 minus 1 over 3 minus 1. And that's going to be equal to negative 5 plus 1 over 2, which is equal to negative 4 over 2. And that gives me a slope of negative 2. Now, that puts us right back to where we were back here. Back here, we were given this slope, and we were required to find a variable, and now I can go ahead and do that. So I'm going to go one more time, y2 minus y1 over x2 minus x1 is equal to my slope. So I'm going to say, because I'm now using this pair, I'm going to go back and say that that is 5 minus, and I'll use this guy here as my x1, y1. 5 minus a minus 5 over, there's my x2 is going to be my d minus 1. Oh, pardon me, not minus 1 because I'm using the other pair, minus 3. And we figured out that our slope was negative 2, so I can put that in now. And I get this being a plus 5 because I'm minus 5. Oops, pardon me. Wow, I'm just writing things wrong today. That's going to be a plus 5, which of course gives me 10 over d minus 3 is equal to negative 2. I multiply both sides by that d minus 3. Those cancel. This distributes, and I get 10 is equal to minus 2d plus 6. I subtract, and I get 4 is equal to negative 2d, so d is equal to negative 2. And so once more, I'd started off looking for that d in this ordered pair. Well, I now know that the ordered pair is actually negative 2 and 5. Okay, so that takes us to point-slope form. And point-slope form is just a derivation of the normal slope formula that we've been using. So we know that slope, or m, is y2 minus y1 over x2 minus x1. And we can take this and multiply both sides of the equation by x2 minus x1. Those cancel, and I'm left with this guy right here. M onto x2 minus x1 is equal to y2 minus y1. So it looks very similar to the formula for a slope, but this particular way of writing it is called point-slope form. So this is point-slope form. Now, how do we use it? Well, we will use that. Oh, pardon me, I should say this first. Sometimes you'll see it written in textbooks in different places where instead of going x2 minus x1 and y2 minus y1, they write it like this, just x minus x1. It means the exact same thing. Remember that these little numbers are just used to differentiate between two x variables. So when you see it written this way, it means exactly the same thing, just written slightly differently. Okay, so when do we use this? We use this form to find the equation of a line in y-intercept form. Remember, y-intercept form is y equals mx plus b. And we use it to find the y-intercept form if we know one point and the slope. So as an example, you might be asked, find the equation of the line if the slope is -3 and it passes through the ordered pair 4, 2. And so we grab that form, m onto x2 minus x1 is equal to y2 minus y1. And I'm going to say that that's going to be -3 because that's the slope right there. So that's the m. Onto x2 minus, and then I pull the x value out of there. So that's the 4 is equal to y2 minus 2. And so I pull that 2 out. And now this is why you will sometimes see it written in this form, because when you apply this point slope form to a question, you always put the known values into this second placing. And notice how in the way that I've written it with the x2, x1, I'm left with these little 2's underneath. And now they look kind of odd because now that I've plunked numbers in for the other one, they're kind of sticking out. They look a little bit funny. And so that's one of the reasons why you will see it written in that form sometimes. Okay, so having said that, we now distribute in our -3. So I get -3x. Now I'm just going to get rid of the 2, the little subscript, because I don't need this anymore. So -3x, -3 times -4 is a +12, and that's equal to y minus 2. Now this is looking really close to slope-intercept form, so all I really need to do now is say I'm going to add 2 to that side and add 2 to that side, and I'm left with -3x plus 14 is equal to y. Well, I can just reorder that and say y is equal to -3x plus 14. Oops, 14. So there it is, slope-intercept form, slope of -3, and the y-intercept of plus 14. Okay, so I'm just going to do one more example of that so we can see it. Remember the formula is m. I'm going to go and do it in this form now without the x2, x1, y minus y1. I put the slope of 3/4 in there, and I go x minus, so for my x value I've got a -8, and that's equal to y minus 3. So this here, that's actually +8, so that's 3/4 x when I distribute this in, plus 3/4 of 8 is equal to y minus 3. Well, that goes into that, leaves me with 2, so I get 3/4 x plus 6, because 3 times 2 is 6, is equal to y minus 3, plus 3 on this side, plus 3 on this side. Those cancel. And that leaves me with y is equal to 3/4 x plus 9. Okay, so it's not a bad little formula. Really easy to find the equation for the line if you are given the slope and a point. Okay, so where do we go from here? You'll sometimes be given an equation like this, where they ask you for the equation of the line if it passes through 2 points. And you can sit there and say, well, I can get the slope of that line pretty easily because I know that that's y2 minus y1 over x2 minus x1. But that doesn't give you the formula because you wouldn't know an intercept value. But the point slope form would, right? If I use this thing, if I could find out what the slope is, if I could get that m, I could use this to solve what the equation is. So really this is a combination of the two formulas. So I would start off with this, and then use these two ordered pair to get the slope. So let's do that. I'm going to call this one the x2, y2. So that's going to be 6 minus a minus 4 over negative 2 minus 3. That's going to be 6 plus 4 is 10. Minus 2 minus 3 is minus 5. So that's going to be a slope of negative 2. So now that I've got that, well, I can plunk that in over here and go minus 2 onto x minus. Now for my x1, y1, does it matter which one of these I use? No, they'll both work. So I'll use the first one again. So that's x minus 6 is equal to y minus a minus 2. I get negative 2x plus 12 when I distribute that in equals y plus 2. I'm going to subtract 2 from this side. I get y is equal to negative 2x plus 10. So there's my slope that I figured out over here. And there is my y-intercept. And that's the equation for the line. So that is using both those formulas, the formula for a slope and my point slope form in combination to get that equation. Here's one last version that I'll do, and this is, a different type of equation. It'll say something like, oh, find the equation of a line that is parallel to this one, but passes through this 0.45. Well, what do I know about this line here? If it's y equals minus x plus 2, I know that the slope of that line is actually right in here, and it's implied negative 1. That's the slope of the line. And so with a slope like that, I can go back to my point slope form, y minus y1. I can say negative 1 onto x minus 4 is equal to y minus 5. So that's going to be negative x plus 4 is equal to y minus 5. I add 5 to both sides, and I get y is equal to negative x plus 9. And when you look at these two, there's the same slope right in there, the little implied negative 1 that I had up here. And it just has a different y-intercept value. And that makes sense because if I've got, a line that has a slope of negative 1 that passes through a point here at 2, and then I needed the equation of this new line, well, it's going to have the same slope, and now it just passes through at 9. So that makes sense. Okay, so that's the end of this lesson. Please make notes on this, and we will talk about it on Monday.